we're starting into the basics of probability. The first thing that we're going to work with is the counting principle. So the counting principle, we're talking about, okay, how many different ways are there to do this? Okay, so for instance, some of you may have seen this before, talking about a tree diagram. So let's say, for instance, I'm flipping a coin. So obviously there's heads or tails. And then I'm going to flip this coin 4 times. What is the likelihood of getting all heads? Okay, so we can represent this as a tree diagram. So I'm going to have the first flip. I can have either a heads or tails. For the second flip, well, if I say, for instance, I flip a head the first time, then I still have the option of a heads and a tails. And the same thing applies for the tails. I could have a heads or a tails. Notice, this is kind of like a fractal. So then I have the third flip, an H and a T, H and a T, and another H and a T. So you can see where this is going to go then for my fourth flip. If I can get all of them listed here. That's the tricky part. All right, so looking at this outside part gives me the total. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so what is the likelihood of getting all heads? Well, there's only one option that gives us that all heads. You can see I just highlighted it there. So there's only one option, so our likelihood is 1 over 16. Okay, so this is a tree diagram. I'm sure you've probably seen it in junior high, and just kind of a refresher here. So let's talk about the counting principle. The counting principle is based on independent events. Well, let's talk about what is an independent event. Independent events are when you have one choice, it doesn't affect the others. Okay, so obviously we can see that dependent, one choice does affect the others. Counting principle. The counting principle is if an event M can occur in M ways and is followed by an independent event N that can occur N ways, then the event M followed by event N can occur in M times N ways. Okay, event M equals M ways. Event N equals N ways. Total, if independent, equals M times N. Okay, so we'll talk about this. I understand a lot of words, not exactly sure what it means. Once you get to an example, you'll see what I'm talking about. So let's say that I need to make a 4-letter word. With X, Y, Z, and repeats are allowed. Okay, so what does this mean? This means instead of drawing out my tree diagram, I can just multiply it and be done with it. So for the first letter, I have 3 ways. X, Y, or Z. It's my only options. Second letter, I have 3 ways. Third letter, I have 3 ways. Fourth letter, I have 3 ways again because they can repeat. So what that means is I'm going to multiply all of these numbers. This is the same thing as 3 to the 4th, or you can multiply it out, that's fine, which tells me that there are 81 ways. So for you guys, I am thinking of a 2-digit number that can contain 1, 2, 3, 4, and 5 with repeats. How many different ways are there to form that 2-digit number? Looking at this, the first digit, I have 5 options, 1, 2, 3, or 4, 5. Second digit, I have 5 options again, 1, 2, 3, 4, 5. So what does that mean? That means total, I have 5 squared, which gives me 25. So these are all independent because I'm allowing repeats. So let's talk about dependent. This one changes a little bit. So for instance, how many ways can 5 books be placed on a shelf? All right, so first book. How many ways are there? There are 5. Second book. Well, I've already taken one out, so that only leaves me with 4 options left. What about the third book? Well, now I've got 2 books out, so I've only got 3 left. Catch it on here? Now, I'm going to multiply all of these together, and this is going to give me 120 ways. Quick side note here, 5 times 4 times 3 times 2 times 1, that's actually something we've already talked about. 5 factorial is 5 times 4 times 3 times 2 times 1. Magic, huh? We'll talk about this a little bit further. So let's say that I have 10 digits for my PIN number. No digits can be repeated. how many different ways are there to construct my pin? Oh, by the way, pin number, it's 4 numbers or 4 digits. Might be helpful. So for the first digit, I have 10 ways. Second digit, I have 9 ways because I can't repeat. Third is 8. Fourth is 7, so I'm going to multiply all of those, and I get 5,040.